Jumping up a notch now, we're looking at relationship between lines in 3D. So previously we've looked at lines that are on a plane, and what we've done is we've pretty much just made these 2D lines. Now, if we have 3D lines, they can actually, realistically, they can still be in the same plane. They don't necessarily have to be in the two dimensions. They could be, if you think about rotating it up or something like that. So we need to start considering that lines in space, we could be looking at 3 dimensions, but they could be coplanar, which means they lie on the same plane. In this case, they have all the same attributes that we just had: intersecting, parallel, and coincident. So if we think about back up here, we had, if this doesn't necessarily have to be the XY plane, it could be tilted up a little bit and have X, Y, and Z coordinates. And we can see intersecting, parallel, and coincident. But we also now have that, because we're looking at 3Ds, if the lines actually are not coplanar, which means if you think about, like, I'm just going to draw below here. So this line here, which is on your screen, is flat on the dimension of the screen. But if we had one going straight into the screen, like you're looking at it from the end here, going straight down, these two lines never meet. These are actually like skew lines here. So what we actually are looking at here, the first bit of this, is we're looking at, if we've got skew lines, they don't intersect, we can still do the angle between skew lines, but what we do is we consider, like, this angle, this line here that I've shown you. What we would do is this line here would be moved. We would pretend it's translated, and we would get that angle there. Now, because of the way I've drawn these, the angle between these would be 90 degrees, but we could get the coordinates from that. So let's jump into an example, because this is a little bit harder, and this is a line going straight into page. Now, I just want to point out here, this is, I've tried to draw this example as best I can. So the skew line here, you've got to remember that all you're doing is you're translating it to get this angle. So you're sort of discussing the angle between them. The line doesn't actually move. We're just pretending it has for the sake of the angle. So the skew lines will never intersect. So let's look at this example here. We've got line 1 has an equation, line 2 has an equation, line 3 has an equation, which we're going to read out in a minute. Show that line 1 and 2 are parallel but not coincident. So what we've got to do here is we've got to find these direction vectors of these. So this is where it's worth writing our lines in this form here: X, Y, Z. And we've got this first vector here has -1, 1, and 1. So its fixed point is -1, 1, and 1. Plus its constant is S. And then we've got 2, -2, and 4. All right. Now, our next line here is line 2, which is got X, Y, Z as well. And it equals, we got 1. So the fixed point is 1. We got 0, and then we got 3. 1, 0, 3 plus t, and we've got our coefficients of t are -1, 1, and 2, -2. All right, third line we've got for this particular one is going to be so the next one I've got here, we've got 1, the fixed point is 1, -1, and 4. And then we've got our scalar multiple is u, and we've got -2, -1, and 3. So -2, -1, and 3. All right, so show that line 1 and 2 are parallel. So line 1 and line 2 have direction vectors. Now, this first one is the direction vector of line 1, so I'm going to just use that as B1, or actually we'll just go. So this first direction vector, which is 2, -2, and 4, is also -2 times 1, -1, sorry, other way around, -1, 1, and 2, and -2. So that's that one. And so that's line 1's direction vector. And then line 2's direction vector is -1, 1, -2. As B, let's call it B1 equals K times B2. Okay, so it just means they're a scalar multiple of each other. Therefore, B1 is parallel to B2. Now, so we've done part of this. So we've proved they're parallel, but we've got to prove they're not coincident. So therefore, what we do is we pick a value. And so our text has picked quite a smart one. They've gone when S equals 0, line 1 will have a coordinate of, so if this is 0 here, we're going to have -1, 1, so 1, I'm saying 1 a lot, so it's -1, 1, and 1 is line 1's coordinate at that point when S equals 0. And so we need to just pick any point here that line 2 would have this value. And so realistically, if line 2 was to have let's just use this y coordinate because it's an easy one. If line 2 was to have, line 2 has y coordinate of 1, and that means y equals 0 plus 1t when t equals 1. Therefore, line 2 has coordinate. Now, you've got to remember when t equals 1, we're looking at 1 times -1. We're going to have a coordinate of 0. And then 0 plus 1 is 1. And then we're going to have 3 plus 3 take -2 is 1. So it's actually closer than I thought. We've got 2 of these coordinates are the same, but one of them is different. So that means since, sorry, I was just double checking the notes, 1, 1, 1 does not equal 0, 1, 1. Lines are not coincident. Okay, so that's given us those. That's a sort of, we're obviously looking in 3D now, so we've got to start remembering parallel lines have the same direction vector. Okay, show that line 2 and line 3 intersects and find the angle between them. So we're looking at line 2 and 3 intersect, which means we're looking at the x. We're looking at the x coordinate is the same. The y coordinate is the same. And the z coordinate is the same. Which means you're looking at, in this space, you're looking at the first one is -1 plus, did I do this the right way around? I did. -1 plus 2s equals 1 minus t. We've also got, I'm just going to put all 3 in here. We're looking at 1 minus 2u. And then we're going to do, our next ones would be 1 minus 2s equals t equals -1 minus u, and then the z coordinates are going to be 1 plus 4s equals 3 minus 2t, which equals 4 plus 3u. So in this space, you've now got 3 to pick from. So what we're going to do is you're going to solve for 2 of these. So you don't want all 3 variables, even though you could do it for all 3 variables. There is a way to sort of do it. But the idea being, hang on a sec, what am I doing? Show that line 2 and 3. Oh my gosh, I'm embarrassed. Okay, this is line 1, so I shouldn't have put line 1 in here. I'm only looking at line 2 and 3. Okay, so we're looking at negative 1 minus t equals that, so we're looking at negative t plus 2u equals 1 take 1 equals 0. Therefore, 2u equals t for the minute. This means that we can just sub into the next one. So in this next one here, we've got this particular thing here. So we can sub our t value in, which will be 2u equals -1 minus u, which means u equals plus u to both sides. 3u equals -1. U equals -1. I've carried a... I've missed a... 2u... 1 take t. I've carried... This is meant to be plus 2u. Why have I got take 2u? I've stuffed that up here. Sorry, guys, I'm a bit all over the shop on this one. Let's keep rolling through anyway. So that becomes -2u, because that's plus 2u, so negative t. Well, take 1 for both sides. Negative t equals 2u. I can just do that straight off the bat. Okay, that means u, -2u. We add u to both sides. We get u equals -1. Negative u equals -1, sorry, which means u equals 1. Okay, and then this final one here, because we've got these values here, we can now sub that back in. So we've got here, therefore, t equals -1 minus u was 1, which means t equals -2. All right, final one here. Let's put this in. 3 minus 2. This is where we check. -2. And this equals 3 minus, this is going to be +7. And then we've got 4 plus 3 times u, which was 1. Which means that equals 7. So that's a tick. They work. Okay, so we've got a point of intersection when u equals 1 and t equals -2. So like I showed you, is it in this screen here? Like I showed you, did I do it in this one? No, I didn't. In your last section, put this in your calculator and double check. This should give you a coordinate here. And so I'll copy and paste this into the notes, but in your calculator, you should now put in, we're looking at line 2 and 3. So these values here, you should be going, using these in your calculator. But you'll be changing the 3 and the u out, and u was 1. So you'd put that in, and you'd put in -2 here in your calculator. And these should give you the same coordinate out, which they will, and it'll end up being... where's my graphic? Sorry, I'm just grabbing my graphics calculator so I can do this by hand. So you type these in, 3x1 vectors. Okay, so I've got my 3x1s. I've got 1, 0, 3, and then I've got -2, and a 3 by 1 again. So we're going -1, 1, -2, and we should get a coordinate. These should meet the point of intersection here. Should equal 3, -2, and 7. Now, this is only half the question, and I feel like we've been talking forever, so we're going to just quickly jump through this. You now need to find the angle between two lines. So I'm actually going to stop this example because I'm going for too long, and I want to do skew lines. You've got to use your cosine theta equals the absolute value of A dot B, which means you're looking at these particular direction vectors here. So let's just use a different color. So you're going to use B1, which is here. This is B2 actually, because it's the second line's direction, and B3. So we're going to put in there B2 dot B3, and they are the direction vectors there. Go back to blue, and then you will solve for these, and that will give you the angle between these two lines. All right, but super rushed, and so obviously not the best. You've also got in your graphics calculator, so I will put these in afterwards. You can use your graphics calculator, check the notes, graphics calculator, but you use the angle vector. You've just got to be careful that one doesn't give you the angle between, it doesn't give you the acute angle. It gives you just an angle, so you need to work out what the acute one is. Okay, show that line 1 and 3 are skew lines, so we need to solve for line 1 and 3. Let's drag them down. Oh. So line 1, and what do we need? Line 3. We're going to drag them. Okay, so we've got to show these are skew lines. So you got to remember that skew lines don't intersect. So we've got to find, because the first thing here I'm going to talk about is they're not parallel. So realistically, if these lines, because of these direction vectors, you're looking at this first number here, I'm going to write B1 is not parallel to B2. Okay, so that these are the direction vectors. Now, in the textbook, they do this second, but realistically, because the twos are the same, and then we've got -1, -2, and -1, we can tell that they're different. So now all we need to do is we need to just check they don't intersect. So if these don't intersect, lines don't intersect, they are skew lines. Okay, so this means that you're looking at the x coordinate is -1 plus 2s, would have to equal 1 plus 2u. We're looking at our y coordinate is 1 minus 2s. Okay, and that would have to equal -1 take 1u. And then our last one there is 1 plus 4s, and that would have to equal 4 plus 3u. And so we would solve these ones simultaneously, these first two. So let's just go in just to, if I'm zoomed in, it's a little bit neater. So if I get 2s minus 2u equals, if I add 1 to both sides, I get 2. So this is 1, 1, 1. And then this other one is going to be -2s plus u. And then if I take 1 for both sides, I get equals -2. So if I put these together, I would get here that u equals 0. And -u, so that would be 0 equals 0. So then I can sub that in, and I get, therefore, -1 plus 2, let's even use this one below it. So we've got 2s minus 2 times 0 would equal 2. Therefore, s would have to equal 1. Okay, so we've got our two different values that work for this particular example. So now we sub them into this last one here. We would have 1 plus 4. We worked out s was 1. It gives us a 5. And then we've got 4 plus 3 times u was 0 equals 4. Do not equal. Do not intersect. All right, so that's it for those there. I'm going to leave it at that. That's a big enough video for the minute, and I'll put those notes up. I'll try and put a graphics calculator example in.